Today I was going to have a go at fitting one of these K40 upgrade kits onto my K40 Xtreeem machine. That seems like a bit of a waste of time and a little bit of a waste of one of these kits that somebody else can have. These parts are copies of the parts that I fitted to that machine, and today's video is all about this upgrade kit for the mechanics. Now, it's been a bit of a puzzling exercise for me to work out the best way to get these pieces of kits to those that are interested. First of all, I've sent one of these kits to China, to Cloudray, and they are very interested in making these kits available on their website. But of course, the one thing I must point out to you is watch the video series very carefully, and you'll see that I started off with a very basic, very basic K40 machine. Now, there are lots of variations of the K40 machine, and I advise you to look carefully at the following video of what's in this kit, because these pieces may not suit your particular type of K40. So after I created the K40 Xtreeem machine, there's been a lot of interest in people wanting to get hold of kits to upgrade and modify their machine, which is the reason why I've designed and developed these particular kits literally as a bolt-on kit for your machine. I've tried to supply all the mechanical pieces, the springs, the screws, the fittings, so that you don't have to buy anything extra, because buying a few screws, buying a few springs is a very expensive exercise. I've bought in bulk. I'm not making any profit on this. You're not being in charge for the labour involved. I'm only trying to recover my basic costs, out-of-pocket expenses on these. So the price that I'm charging for these kits is £109, but only when I know where you are in the world, and if you're interested, can I provide you with a quote for getting these pieces delivered to you. Now, there are 17 kits here all ready to pack and ship to those people that are interested. The question is, how do you get in contact with me? Well, I think the easiest way is via the laseruser.com website, where the videos appeared. There is an opportunity in there to reach me through their website, and you can request pieces from me. Now, three things to bear in mind. Once these 17 have gone, that's it. I don't intend to produce any more. Hopefully by that time, Cloudray may well have kits available for you to purchase from their website. They may not decide to supply them, but there is an alternative that might help you. The guy that runs the Laseruser website is in the process of coordinating with makerspaces in the US who want to get hold of machines from China which are not K40 machines. They're K40 shells. Because if you go back and look at the video series, you'll see that I ripped most of the guts out of the machine. So the point is, why do you buy a cheap K40 machine with half its pieces already installed, which you're going to rip out? So between him and a guy in the States, they decided the sensible thing to do would be to see if they could organise kits of parts along with a base machine. You don't have to strip the pieces out, you have to fit new pieces in, and you haven't got to pay for the pieces that you've got to strip out and throw away. That's something that's being organised, and I'm nothing to do with that at all. So you can make your inquiries directly with Gareth at the laseruser.com website. Now, we will go and have a quick look at the machine in a few moments, because by now I think the whole of the series of 8 videos will have been published. Now, I say 8 videos because after the first 6, which produced the machine, I then decided that there was potential for using this machine for making your own rotary system. I've designed something that will fit this machine and do things like Yeti cups and bottles. It has certain limitations, but hey, this is a very small machine, and I'm trying to make it as close as possible to the capability of these bigger machines that I've got around me at the moment. So the following video that I've done is all about making the pieces for this kit and all the fixings and fittings that are needed for this kit. Most of the holes that I'm going to put in here are M3. So I've got an M3 spiral point tap on there, which is a proper machining tap. You can buy proper tapping oil, but to be honest, for years I've been using this stuff. It's a moly oil. It's an additive. It prevents aluminium binding onto the tap. And that's it for the M3. There's two M4 holes that got to be tapped on the end, but we'll do those later. Well, I've got my M3 tap in here. I'm going to actually tap the tube holder itself. So this is the channel in which the tube rests, and there's just two M3 holes in the bottom. Now, sadly, my drill is not deep enough to be able to tap these holes in the end here. So I've got to tap these with my hand drill. This is an M4, and it's just a matter of making sure that you hold it square. If they're making them as a flat blank before they bend them, then the right thing to do is to tap the holes before you actually bend them. But hey, I didn't have that option. I bought these already bent with holes in, ready for tapping. So now we've got to put some M3 tapped holes, 3 of them, in this number 2 mirror bracket. And now we've got to put the M3 in these plates, which are going to go onto the tube mount for number 1 mirror. Well, I've got the nice solid base of my fly press to do the next part of the job, which is to assemble the number 1 mirror plate onto the tube holder. I didn't want to weld this on. The tab there to drop in that slot. Now it goes in, but it might need a little bit of help from a hammer. And that pushes it in nicely square against that edge. And then if they've bent these pieces right, those tongues should push into that side there. Now you'll find that there are little pointy bits left on the side here. Well, they're purposely left on the side there so that you can get a hammer and flatten them. They effectively become little rivets. And that plate is now secure in there. So here's a 50mm tube mounted on this channel mount. One of the biggest concerns that I had when I modified these parts away from, I had acrylic versions of this to start with, if you remember, that were 8mm thick. Now my plan was to make 2 of these out of 3mm thick material, aluminium, and bolt them together. When I came to test the shape that I'd originally used for my acrylic version, it's sort of hanging there on a thread just on top dead center, and if I give it just the slightest amount of touch on it, look, pop, it comes off. So that's totally unsatisfactory because it hasn't gone over center enough. So there must have been some flex in the acrylic that I used that isn't here in the aluminium version. So what I've had to do to solve that problem is to actually manually modify the shape with my Dremel. And now, beautiful. But I will modify the drawing so that it doesn't happen in future. The good news is that I only need 1 of these, not 2. They're totally strong enough on their own as a single item to do the job. Okay, so now we've got a large pile of M3 holes to tap. This is the mirror holder, and it's obvious which holes are which. The ones in the corner are obviously going to be tapped. The next thing we've got to do for these mirror holders is got to turn them into this shape here. Okay, now we do that with the aid of this little bending jig here and my fly press with a little V-bender in it. Now this jig, you can't put these pieces in the wrong way because they don't fit any other way except there. Just pull that round till it touches the stop. It's pretty amazing what you can do with acrylic, really, isn't it? Just a simple acrylic jig. The perforations on here will actually make the bend go in the right place. So if you gently just touch it a few times, it'll automatically centre itself, and you'll see that the bend is such that, look, the actual little tongue there is going to drop right into that groove. It's a bit snug because, again, I think they've made the holes a little bit on the tight side. Now here we've got my standard Mark II head, which we're going to prepare as well, because we're using this standard head on the K40. Okay, so now we've tapped these two holes, we're going to use the same fixture that we use for bending the mirror holders. So it's the same as before. Basically, we're going to drop that in there. I'm going to bend that through to 45 degrees. Now, to bend these heads, I've got to be careful that I don't bend this tab here. Okay, so I've got to stop my bending at the end of this dot here. So I've got a little location thing on here, which A, sets me square, and B, stops me getting too far into that corner. It doesn't matter if I stop about 1/8 of an inch clear, because the bend will project into that corner anyways. I've never made large batches. My productions have always been 1s, 10s, 20s. So, you know, I have to make do and make my equipment as flexible as possible. So this might look crude, but it's completely effective for doing what I want, for a 20 or 30 off. I can bend these like that, and then if the slot doesn't quite line up, just push it and it drops in. And it just rivets over. Just check finally to make sure that the last one in the batch is 90 degrees, and it is. Now we've got these liners that go inside here, and they've got to be bent at 90 degrees also, but there's a hole that's got to be tapped in there. There's an M3 hole. Now the bend on these pieces can't use the same end stop because 2mm difference. So I've got to use a different end stop, and again I've got the press set to 90 degrees, so hopefully that looks pretty good for 90. Now the great thing about the perforations in here is it forms a plane of weakness, which even if the bending tool is very slightly out, it'll follow the plane of weakness. At the moment there are two types of mirror holder. One is the standard mirror holder that I use for the Mark II lightweight head, and it has only got two holes in these corners. There's a pair of holes here and single holes in the opposite corners. Now for the mirror holders, I changed the design slightly, and I've put 3 holes in the opposite corners, because sometimes you'll want to have the adjusting screws on the back of the mirror, because that's where you can get access. But because of the K40's limited access, I've put some of the adjusting screws on the front where they're much more accessible. If you're making a CNC version of this, there's no reason why you can't put 3 holes in everything. You can use this on the Mark II head as well as on the mirror holders. So this is a much more cost-effective process for me to go through, because I'm already cutting pieces out of 2mm aluminium, and I'm going to be fixing them together like that to make a single mirror holder. Before we can tap these mounting holes in the corner, what I've got to do is I've got to fix these 2 pieces together, and I do that by a screw in these diagonally opposite corners. So the first thing I've got to do with these pieces is to tap M3 holes into these diagonally opposite corners so I can assemble this, and then as an assembly tap these 3 holes. So you can see it's quite a complicated little process, but it's fine for me as I'm only making a small batch, 60 in total for 20 kits. The first part that we have to do was to put them together so that they look like a mirror holder. 2 pieces of 2mm screwed together. One of those screws is there permanently, the one on this corner, and the other one is a temporary fix, because we have to hold this together solidly so that we can then tap the holes that are in the corner. And in fact the CNC version of this has got 3 holes in it, and that hole only not this hole here, because you don't need that hole if you're making it from solid. To make sure these pieces go together the right way round, what I'm going to do is on the drawing, I'm going to modify the drawing, so just here I'm going to put a little notch, and here I've got an M3 by 4mm long posi panhead screw. Now it must be 4mm long. The screws do not come through the front there, and that's quite an essential part because I need that to sit on a flat surface so that I can tap the corner holes. The liner fits inside there, and this hole on the end here, the slightly slotted hole, takes an M3 screw and holds the liner into here. Now there are lots of extra pieces on here which are not required for the K40. You'll find that there's a bent section here which is not bent at the moment that matches up with this piece here. This is for locating it on other brackets for other types of machines. So this is developed into quite a universal piece of kit, and that's what these holes are here for. They're for fixing onto yet another type of bracket. So we shan't be changing away from this universal head. We've got two tapped holes in the end here, remember, which are for the mirror adjusting screws. We've got some M3 grub screws, 10mm long, which are going to be used to adjust the mirror. So we're just going to pop those in there and take them through about 1 or 2mm projecting through. Again, all of these little things, they're tedious little jobs which have to be done. I wouldn't want to send all the parts out loose, so we have this head assembly already pre-assembled. Okay, so now lots more M3 tapping. The next simple little job, but again tedious because there's lots of them to do, is to take these flanged button head screws. Flanged is important because these are going to hold the mirror in. What I'm holding on the end of that key is close to £1. It's a silly amount of money for a very small screw. It's M3 by 4mm long. These just happen to be all I could get, and they're in stainless steel, which is another reason why they cost nearly £1. There are two holes which are diagonally opposite that hole in the centre there, and those are the screws. They are the positions that the mirror needs to be held into, and you can see that they overlap the cavity and catch the corner of the mirror in just two places. You don't need to tighten them up very, very tight when it comes to clamping the mirror in. You just need to clamp the mirror in just gently. And then stage 2 is actually disassembly. So we're going to take the screw out of this very small corner here because we don't need it anymore. In fact, it's going to get in the way of mirror adjustment. And there we have our finished mirror holder. And that's now ready to be assembled into the head. So I've got two springs here, which I should give you the specification for, and two M3 posi panhead screws again, which are 20mm long. Now they're 20mm long for a good reason. They're going to stick through the front of the mirror very slightly. Put the spring over the screw and the screw through that hole. That fixing screw there sits on this top right hand corner here, like that. And then we can just manually screw the mirror, and then a spring and a screw into the top corner as well. Now the screws will come through by about 3mm. Before I ship these, I always set that you can wind a screw in so that that gap is not level. I always set that gap roughly level with that screw there, and that's 2mm all round, and that's enough of a gap to give you the mirror adjustment. Okay, now these projections through here are so that you can plug a target onto the front there, a special target, card target, if you want to. Well, finally we've got a couple of fairly simple jobs for the fly press. These little brackets, very thin, you can put them in a vise and bend them across that plane of weakness there. Now, I've got an end stop set up on my little press here. These will naturally bend along this plane of weakness. I would prefer to make them all the same in my fly press, that I can set it up so look, they're bent at exactly 90 degrees. This next part which is the butterfly clamp, and I've got this rather superb, I really mean crude, piece of tooling, which is basically 45 degrees on each side, and I've got a screw in the side, in the end there, an M5 screw, which locates this so that it can't pull out of line when I bend it. So I just make sure it's sitting in there square, and then I'm going to let this align my tooling for me. It's approximately in line, and there we go. So I'll now clamp that tooling up. Okay, so now it's absolutely spot on 90 degrees. Okay, here's another one of my very simple but crude jigs. We've changed the tap now to an M5. I've got this jig here set up so that, look, it can't twist, because when it sits on this, which is part of a curve, it sits upright and the tap will automatically centre it, but it can't twist because it's held in the jaws of the vise. Because I've got to stop it from lifting off on the return stroke, all I do is hold my fingers on there. It's completely safe. Just drill a hole, and now that's why I have to stop it from lifting off. Okay, well here I've got some M5 by 8 cap edge screws. Doesn't matter what colour they are, these happen to be what they call self-colour, which is black. Very convenient, because we're going to add to these one of these things. It's a little thumb wheel which presses onto the top of a cap edge screw. The only problem with these cap edge screws is they've got a dished end in there, and if I leave that dished end in there, it's going to put all sorts of marks in the surface of the lens tube. So I have to go onto my little belt grinder here, which is going to make a bit of a noise. I rotate it so that it's got a reasonably flat surface on it, very slightly domed if anything. And then it's back to the vise, where you can gently pre-assemble it. But then we've got to pop that in the vise or under the fly press. But most people will have a vise, most people won't have a fly press. And then you can just literally put it in there and squeeze the vise up until the head of the screw just disappears flush with the surface there. And there we go, we've got a nice little screw that passes into our butterfly clamp. When we assembled the mirror holder for the standard Mark II lightweight head, I used stainless steel button head screws, which I said are pretty expensive, but they also take up a little bit more room and overlap the mirror more, which is great, which is the original design intention that I had. But when it comes to these mirror holders, we've got a slightly different situation. And if you remember, we've got 3 holes in each corner. One of them's for the mirror clamp here, like this, with its flanged button heads, and this one at the back here is for the fixing springs, and this one is, well, that's a special that I've added that allows you to put an adjusting screw in from the front, because these mirrors are difficult to get to from the back. So I've allowed you to modify and adjust the mirrors from the front. The only problem is the closeness of these holes, there's a tendency for it to just overlap with the flange on this button head screw. So I've had to look at an alternative way of tackling this problem. So the M3x10 grub screw goes in that top corner and this bottom corner. And we'll wind them through so that there's about 2 millimeters projecting through the other side here. Okay, now that we've got those 2 screws in, we can remove this corner screw. This is just the assembly screw. And then I've got these little standard M3x5 button head screws, and they will hold the mirror in. There's just enough room around the outside of this button head screw to allow the adjusting screws to run in from the front. There is approximately a 1 millimeter overlap on the edge of the mirror. This happens to be a glass mirror, the lowest of the low mirror, which is the sort of thing that you might want to use on a 40-watt machine. I always recommend that you use solid metal molybdenum mirrors. You'll have no problem with clamping them down because you won't get any distortion and there's no chance of cracking your mirror. These are the same 20 millimeter long pan head screws, M3. Put them down the center of the spring. So the pivot point there goes into that top right hand corner, just there. and it's the top, the only remaining hole there, which allows you to put the screw in with the spring. Okay, then you can wind it through so that there's approximately 3mm of thread sticking through the front of the mirror, and that will give you approximately the right tension on the springs, and it will also provide somewhere to plug a target onto for aligning the mirror. Now again, what we're going to do is make sure that we set these grub screws here to give us roughly a parallel dimension here and a parallel dimension here. If for any reason you don't like these adjusting screws on the front here, you can always take them out and put them in the back corner here where they were originally placed. Now, although it's not required for the K40 head, these are still going to be manufactured as standard Mark II heads, and we need a countersink in there. Now, it's possible I might be using that. I used that on the first iteration of the plate, the mounting plate that goes on here, but I'm going to try it with the short head mounting plates so that it's very easy to swap heads over. Nobody can use their machine until they've mounted the head onto the slide, and if you haven't got a machine you can't make this piece out of 3mm acrylic. So this is an essential part of the kit as well. This is manufactured from 3mm acrylic, and it allows us to mount the head on to here using this tongue. This slot here is very accurately manufactured at 3mm. So the idea is that this tongue here accurately locates in this slot that's here and prevents rotation when you adjust this up and down to reposition the beam in the Z-axis. Now, sounds like a nice idea, but the problem is 3mm acrylic. It's never 3mm. If you buy extruded acrylic, you may well find that it's 2.8, 2.9. It'll rarely be 3mm exactly. And if you buy cast acrylic, well, it's an even bigger lottery. There could be as much as plus or minus 0.5 millimetre on this 3mm dimension. Generally it's in the region of about plus or minus 0.2, but theoretically the specification says it can be plus or minus 0.5 mil, and that could be a total disaster for the function of this little guide pin here. Let me just illustrate this for you. Now, I have a very friendly plastics distributor near me, and he allows me to pull in his scrap bin and take pieces as and when I need them. So I've got all sorts of odd shaped bits and pieces of acrylic that I can use, and see that the size of this is pretty good, 3.04. And if we check that fit in this slot, even 3.04, well, it really is a snug fit. I mean, that's absolutely perfect in some ways, but it's just too perfect because it doesn't allow it to slide. Okay, but that's 3.05. Now, if I look at the other corner of this very small piece of material, we find the dimension is 3.15. That definitely will not go in that slot. But this is 3mm cast acrylic. Now, I've got lots of bits of acrylic in this workshop which I've searched through. I've got a lovely sheet here, and here we are in this corner here, 2.98. Snug, but nice fit. This corner here, 2.99. So this looks like a perfect piece of material. All right, I'm now going to literally just turn it upside down and look at the other corners a metre away. 2.5 and 2.7. I mean, this is absolutely ridiculous. So even though there's no labels on it, this is a piece of cast acrylic for such a large tolerance. So if I work across this top edge of the material here, I probably will be able to get the size tenons that I want. I suppose in general terms I was pretty lucky with my selection, because look, we go from 2.96, 97, 0.98, 0.99 to 3mm dead, 3.01 and 3.02, and I've been through and I've carefully selected and graded these. Yeah, this is a lovely big caliper, but it only cost me around about £12, so it's actually not what I would class as a top grade unit. It's okay and it does a reasonable job, but for example, let's take this 3mm one. I've set it to 0 and it reads 2.95 there. and 2.99 there. If I take this one, a different one, read 0, 2.94 there, and 3.01, 3 millimeters dead there, and that's the one that I used. Now the main reason for that difference is because although you tend to think of a vernier as being accurate just here where this pointy bit is, where this narrow piece is, in reality if you hold this up to the light and set 0, you'll see that the contact point for 0 is actually just here, not down here at all. There's about a 0.02 or 0.03 gap at least down here. So that is actually the 0 point, and that is where I've been measuring these from, 3 millimeters. How do those dimensions feel in this slot? Now technically 3 millimeters should be a nice wobble free fit in that slot and go up and down smoothly, which it does. Let's try a 3.01. Snug, but hey, now I like that because that's got a little teeny weeny bit of resistance, no wobble on it, so that's a very accurate fit. 3.02, snug, but still feels good. So we really, let's try these 2.99s. Yeah, they're really easy, and if I try and twist them, I can feel a very small amount of wobble. 2.98, very definite wobble. So we've got to discount those, and hopefully we've got 20 here. 19, 22. How lucky am I? So those are the tenons that I need to make my 20 kits with. And now realistically it doesn't matter what thickness this material is for the other parts of the job. Well, there's the first 12 sets. Okay, now these two pieces that we've just cut require a little bit of work on them. This one, with the hole in it, has got to have 4 countersink in those positions there to take countersunk, M3 countersunk screws, and that will be an M3 by 10 millimeter long countersunk screw. This other plate, we've got a job that really, from a practical point of view, I found is essential. You may decide not to do it on your kit, but the user really ought to do something like this to make life easier for himself. So I'm going to do this on the kits that I supply. Turn it over so that this piece is on the left hand side and this is now the back, and I've got a piece of normal masking tape here. So I've stuck a piece of tape over those hexagon holes which are going to hold nuts, and then we trim with the edge of a knife. We're not going to cut it off. We're going to run round with the edge of the knife at 45 degrees and just scrape it over the surface, and it cuts it off. So all we're trying to do is to stop the nuts from going through those hexagon holes and stick the nuts effectively to the tape on the back, the sticky surface of the tape. Now we've got to do that for these holes here and these 4 holes at the bottom. Now I'm just using my screwdriver on this one to pierce the holes through this back plate, and this is where we're going to start using these little tenons that we made. Now that tenon drops into there, and it may well be tight, it may be wobbly. So what we're now going to do is we're going to just run down the sides of that with a little bit of glue, and you'll see the glue running into the whole of that assembly. Now we can't guarantee that this is sitting absolutely upright, so we wait about 30 seconds, and while that's going on I'll do another one just to make sure that there's no glue on the surface. But remember, this stuff remains soft for a little while. Then we're going to put the other top piece on top. We're going to leave that there so that we guarantee that the tenon is glued in an upright position. Now, in the same way that we didn't want wobble on here on that tenon, we don't want wobble on that tenon in this assembly, which is why we've glued it to the back plate. Everything has got to be stable so that we get a nice smooth movement when we come to adjust Z. Okay, now you'll see the benefit of having that tape on the back there. And we'll first of all add 4 M4 nuts into there, followed by 4 M3 nuts in these 4 corner positions. This is a push-in fitting to suit 6mm tube. And we'll push that through from the front side where the countersinks are, because there's a very slight taper on that hole and it goes in smoothish but with a little push. We've then got to hook the narrow waist of the fitting into that loop there that we've got on the back plate. Okay, now that captivates the fitting. We can then press the 2 plates together, and there we've got our basic assembly with the nuts that don't fall out. We're going to drop in the 4 fixing screws, and these are M3 by 10mm long countersunk screws. They're going to fix this head to the bearing. These screws are completely loose. The object of the exercise for me is to make sure that you get a kit with all the screws to do the job, and we don't want to lose these screws. So what we're going to do, we're going to take the standard Mark II head and we're going to plug that onto this mounting plate. Now we should be able to plug it straight onto this tongue that's in here so that the head slides up and down. Now if it doesn't slide up and down completely smoothly, and it's good that it's stiff because it does mean to say there's no movement, but there is a possibility that because of the way that the laser cutting takes place, there may be a small burr along the back edge of this slot. So if you take something like the edge of a screwdriver and just run it along the edge of the slot, it'll take that burr off, and it should then drop on there smoothly and run up and down there without any twist. You'll see that in doing that we've covered over 3 of the 4 fixing screws. If we drop the head down to the bottom of its slot like that, we'll cover up the 4th fixing screw as well. So we can then bolt the head on with an M4 8mm long posi panhead screw. The panhead is the most important part of that description because, and I'll show you in a second, this panhead screw here is the most important one, and why they're panheads. The low profile of the panhead allows this lens tube to slide past the head of the screw without hitting it. If it was to hit it, it would move the lens tube out of position. So we're now going to add the belt clamp system to these 2 positions just here. And we do that with an M3 10mm long panhead. Any head will do really, but panheads are usually the cheapest sort. Now if we take a look here, you'll see that we've got 2 M3 washer styles. This is the standard M3 washer, and this is what they call a Form C M3 washer. It's got a much bigger outside diameter for the same size hole in the centre. So that's important. We want that Form C washer to clamp the belt. So again, we're making use of our captivated nuts that are in there. They're not going to run away from us because they're held in with the tape. And I'm going to wind the screws in so that they don't escape. And I think we've got all the fixings required to just straight bolt this head onto the machine. You haven't got to go out and buy anything extra, because the whole point of this is you want to bolt this head on the machine and get it to work. That's why we're supplying this acrylic mounting plate, because you can't make that if you haven't got a machine. Once you've got a machine, all sorts of things become possible. So the only thing really left to add to the head is the butterfly clamp, which fits on there. A V-block will always present a true repeatable position. So all we do is tighten that up, and we've locked this in exactly the same position every time in terms of its position relative to the centre of the mirror. If we need to take this out, all we've got to do is undo that, lift the clamp off, and look, the lens tube comes in and out without having to drop it out the bottom of the holder. So that's one of our major sub-assemblies all ready to fit to the machine. Well, we're now going to gradually add screws to the rest of the kit to make sure that all the screws are supplied. This is the number 2 mirror bracket, and to fix the mirror to the bracket we've got an M3 by 6mm long posi panhead screw with a 3mm washer. Now to fix this gantry to the Y rails we're going to need some M4 screws, and these are M4 by 12mm long, and we've got 4 of them. There seems little point in putting all these screws in, so I'm going to drop those screws, those 4 screws, into a plastic bag, and then to fix the rail on with these we need some M3 screws. Now it might seem a little bit like overkill, but these are 16mm long, and they're 16mm long for a good reason. They will need to project through the back. If you want to put the LED rail on here, you can use this projection to mount your LED rail, and to retain the LED rail you'll need 5 of these M3 nuts. Now in this plastic bag I'm also going to put the number 1 mirror bracket and this thin flexi bracket for the other end of the gantry. So these are all gantry related items, and you will need 4 fixing screws for the bearing for that bracket. So those screws are going to be M3 by 4mm long, because there's very little room inside the bearing to take a length of screw thread. Now the hole on the end here is to take the micro switch. The micro switch already has its own fixing screw and nut, and it just has to poke through that hole there. So we're going to add the clamp screw for mirror number 1. This again is an M3 by 6mm long panhead screw. Now the channel for the tube mounting sits on a spacer. We have to lift the tube up by 12mm, and so this bolts onto here with a serious offset. That's going to cause the whole packing to get bigger. I'm trying to keep the package as compact as possible. A slight mistake on my part means that these holes in here in the bottom of this channel are a little bit on the big side, and they don't really tap properly. So we've got these M3 by 10 posi pans, so you screw those through the tube. The thread might not be very good, so it might get a certain distance through and then just drop through, and then fix it in place with a nut underneath, an M3 nut. And you should be able to spot through in the centre of these slots into the base of the tube enclosure and fix them down. I've got an M3 by 16 if you put a tapped hole in. If not, you'll have to put a nut underneath. So we'll include fixing screws for the tube holder in that same plastic bag that we did for the gantry. Now they will be obvious because they've got nuts on them. Okay, so that one's 16mm, M3 16mm long, and that one's M3 by 10mm long. So we're gradually getting towards a full kit. I may well also, I think sensibly, put the butterfly clamp in that plastic bag of fixings as well. And the 2 remaining parts are the mirror holders. And look, they very conveniently fit inside that channel. I've crudely designed a tri-wall box that will package these up quite nicely and strongly, because physically they're very, very stiff in themselves, and look, by the time we package them together like this, they're stiff in all directions. So just a tri-wall protection is all it really needs. Now because it's too bulky, I've had to take the air assist fitting out of here for packaging. There's a chance that these screws on here will scratch the inside of this aluminium. but it doesn't matter because it's face down once it's in the machine. Then we'll put the fitting in the plastic bag. Well, look, those mirror holders will actually go in the bag, which is great because it means I can tuck the bag in there. What I've done also, I've made this and these pieces slightly pulled apart so that they fill the available space in my packing, because I'm using a standard box here with a bend line on it. I'm cutting it up and I'm folding it how I want it to fold. So I'm making use of a very convenient piece of, let's call it scrap material, which I got from somebody else. Now I put our piece of tape on there, fold it up and snuggle that really tight. And then our final move will be to put a piece of tape right across the join. So here you see the little rotary that I've designed and made on this machine. I messed up the X-axis motor, and what we've now got on here are two small, very similar NEMA 17 motors, which are ordinary 200 steps. The one that was supplied on here was a 400 step motor. You can see how to produce this item in videos number 7 and 8 in the series that you can find on lacyuser.com. One of the issues that arose when I came to use this kit was that we didn't have enough depth in here to put items on here and engrave over the top of them. The standard lens tube assembly that I had on here, we've got this adjustment up and down on the lens tube. Much simpler, easier and quicker than a Z table. The problem is this is too deep when we put this in the machine. I've had to design a different approach, a much shorter head that's fitted on the machine at the moment for when we want to use tall components, like maybe jewellery box or something like that, or when you're trying to engrave large components on this rotary system. So basically we've got a system here which uses two heads now. One head uses a long adjustable tube, and you can use that same tube on here as well to get a range of adjustment, but it's a different range of adjustment. But if you really want to get very short, so we've got a different lens tube here which allows us to get much higher, and that's all described in video number 7 and 8. Now, one of the things that you can do with this machine is fit a very small dot engraving lens called a compound lens, which you can buy off the Cloudray website, and it's supplied like this with two lenses in it which produce a compound lens which gives you a focal distance of around about 10.5 to 11 millimeters. It is normally supplied with a piece of tube which fixes in the side here, but it works, and that's how I designed it. But in practice it's a little bit inconvenient. Now, if you're going to build one of these rotary devices, you're going to need a little bit of 4mm tube. Cut a little piece of that 4mm tube off, put a 4mm drill into a hand chuck or something, and physically just use it like a reamer and just force a 4mm drill through the hole that's there. You'll be able to tap in a short length of tube like that, so that you've got a very easy and simple method of plugging on this 6mm tube with a 4mm bore silicon tube that I'm suggesting you buy to make the air assist system. So as I said, I'm not going to go through fitting a kit on this machine because this is all there and it's working. As part of the head kit, I provided this rather special acrylic head mounting plate. Now, it's purposely designed so that it's short to take this short head. The one that I originally designed was long, using this head. Now, I've tested this head and that head with the 1000mm a second engraving test, and it works perfectly okay. There's not a problem using either of these heads, just depends how deep you want to get down into your workspace. For those people that do want to go into this rotary kit, I have got a small batch of these short heads that I've manufactured, and I can supply these short lightweight heads. There's a little bit of difference in material, but basically there's no difference in the cost, because I mean the material is a few pence difference, but the main cost is in the basically the assembly, the parts that go onto it. Now, if for example you do not have the facilities for manufacturing this fascia plate with the illuminated sign on it, well, it's not essential. It just makes it look pretty, and there is a certain safety aspect here which I've used, which has got some depth on it to catch any reflected rays that come out. I think the risk of you receiving anything from a 40-watt tube that comes out of this gap is probably maybe even less than being struck by lightning at the same time you're picking up your winnings from a lottery. So the final comment here really is, any news either by me or by Gareth that's happening on this machine will be appearing on the laseruser.com website. So remember to visit that regularly so that you can keep up to date with any changes or updates that are made. I'm not planning to make any more videos on this, I just plan to use the machine because, hey, it's a lovely little machine and I love it. Maybe I'm going to discover something that I want to tell you about this machine, and I will add another video to the series. So thanks very much for all your support and your interest, and good luck to you guys that attempt to do something like this. It's a worthwhile exercise. Oh, one thing I forgot to mention. Now, this machine is running. It's not doing anything, it's just running, and we're circulating the water through the system over there. Now, if you watch very carefully, you'll see that that temperature, 24.2 it was just a few seconds ago. It's now going up to 24.3, and I suspect within the next minute or so it'll be up to 24.4. So well, hang on, why is that temperature rising? This machine has already been in this workshop permanently for several days, and so the ambient temperature is lower than 24. There it goes, look, 24.4. What's actually happening is the 25-watt circulation pump is actually heating the water. You can see how quickly it's going up. We're not putting any temperature into this at all from the tube. The only temperature rise that you're seeing there is because of the energy that's going into that water from the pump itself. Now, that's a great feature to remember if you happen to be in a cold environment. When I first had these machines, I used to put in lights and things like that to add additional heat to make sure they didn't freeze up during the winter months. Well, it turns out that really all you've got to do is leave them turned on and keep the water circulating, because the low wattage from the pumps, even though it's 25 or 30 watts, is enough to keep the water above freezing temperature and circulating. So just in the space of the few minutes I've been talking, it's gone up from 24.2 to 24.7. Now, part of the reason for that is because I've got a relatively low volume of water in the system. So my plan is to double the capacity of that system. That should slow down the rate of temperature rise. Now, there's only a certain amount of temperature rise that the pump is going to put into it. Okay, but it may well be that we run this tube at 35 degrees C, for example. You can run the tube up to 40 degrees C. And I've run tubes up to 45 degrees C for several hours, and the only difference that I've picked up is about a 5% power loss at 45 degrees C as opposed to 18 or 19 degrees C. So there is a small effect, but it's not going to affect the life of your tube. Thanks for your time and your interest, and good luck with your project.